Hello everyone, welcome to my video. I am Kshitija Wadverao from Sri Siddheshwar Women's College of Engineering, Solapur. Today I am excited to share my presentation on one of the topics of basic electrical and electronics engineering. And I hope by the end of this video you'll see why. Let's dive right in. In this presentation, I'll be discussing upon DC motor. So let's get started. So basically, electrical machine, it is divided into two types, DC motor and DC generator. The function of DC motor it will convert the electrical energy to mechanical work, and the function of DC motor is it will convert mechanical work into electrical energy. This is the basic difference between DC motor and DC generator. Now we will see DC motor in detail. First of all, we will focus on construction of DC motor. Here is the detailed diagram of DC motor. The components of DC motor are as follows: commutator, shaft, brush, yoke, pole show, magnetic path, terminal box, fixing hole, main pole, armature, field winding, armature winding, and brushes. As you can see the diagram. Let us see the detailed explanation of the components of DC motor. The construction of DC motor is as follows. DC motor consists of the following parts. First is the yoke, that is frame. It is the outer cover of the motor. It is made up of cast iron or steel. It provides mechanical support and acts as the path for the magnetic flux. As you can see in this diagram, yoke is the outermost layer of the DC motor. It provides the path for magnetic flux. Next is the main pole. Main pole is mounted on the yoke. They carry field windings and produce the magnetic field required for the motor action. As you can see here, there are four main poles, that is north, south pole, and it is mounted on yoke. Let's see the next component, armature core. Armature core, it is the rotating part of the motor made up of laminated iron sheet. It reduces the eddy current loss and provides a path for magnetic flux. Next is the armature winding. Armature winding are the copper conductors placed in the slots of armature core. They carry current and experience force in magnetic field. Commutator. It is a cylindrical structure made up of copper segments. It reverses the current direction in the armature winding to maintain unidirectional torque. Let us see in the diagram. Here is the armature that rotates, and the armature windings and the commutator is the center part. Let us see the function of brushes. Brushes are made up of carbon and they are stationary and press against the commutator. They conduct current from external supply to the rotating armature. There are more components of DC motor. Shaft. It is the rotating spindle connected to the mechanical load. It transfers the motor's output to the load. Magnetic path. It is a closed path for magnetic flux which includes field poles, air gaps, armature core, and yoke. This path ensures proper interaction between the magnetic field and the armature winding. Next component is the terminal box. Terminal box is used for external electrical connections to the motor, and also it provides a secure point for connecting the power supply. Field windings, these are the copper wires wound on the pole. When current flows through them, they produce magnetic field required for the motor action. These were the components of DC motor. Let us begin with the working principle of operation of DC motor. After construction, we need to see the working of DC motor. Well, DC motor works on Fleming's left hand rule. Now, you might wonder what Fleming's left hand rule is. Fleming's left hand rule states that when you hold your hand, when you hold your left hand such that the thumb, finger, and middle finger are mutually perpendicular to each other, then if the finger indicates the direction of magnetic flux and the middle finger indicates direction of current, then the thumb will indicate the direction of force acting on the conductor. Fleming's left hand rule in short says that the forefinger indicates the direction of magnetic field, that is north to south, middle finger indicates direction of current flow through conductor, and thumb indicates the direction of mechanical force. Then the mechanical force is proportional to the current, then magnetic field strength and conductor length F is equal to BIL, where B is the flux density, I is the current, and L is the conductor length. This is the principle of operation of DC motor. Whenever a current carrying conductor is placed in a magnetic field, a force acts upon it. Then the direction of force can be given by left hand rule, as I explained. Then in motor, main flux is produced by field winding when DC supply is given to the motor. At the same time, armature conductor also carry current. The main flux is directed from north pole to south pole. The armature current direction of current in the upper conductor is given as dot, that is going out of the paper, and while in bottom conductor it is cross, that is going inside the paper. By using Fleming's left hand rule, the direction of force on the upper conductor is found towards right, and on the bottom conductor it is found towards left. Then these two equal and opposite forces produce a torque, and thus motor starts rotating in clockwise direction. This was the simple principle of operation of DC motor. But here only one conductor is shown at the top and one at the bottom. But in practical, it is found that all the top conductors under N pole experience force towards right, and all the bottom conductor under the S south pole experiences force towards left. Hence the armature or the motor starts rotating. Then the magnitude of the force can be given by this formula, that is F is equal to BIL N, where B is equal to the flux density, I is equal to the current in the conductor, and L is equal to the length of the conductor. And that brings us to the end of my presentation. I appreciate your attention. Thank you for watching.